So this question was asked in GATE 2019 Electronics and Communication Engineering paper, in which you have to find a three-tap causal filter which gives a signal, zero output signal for an input in the form of x of n, and the filter coefficient h of 0, h of 1 and h of 2 is given as 1, a and b, and this is the condition of filter that h of n equal to 0 for n less than 0 and n greater than 2. So this filter is live from only 0 to 2. So you need to find out the a and b, that if output is y of n equal to 0 where x of n is given above. So you need to find out a and b. The NPTEL reference for this question is Discrete Time Signal Processing by Professor Mrityunjay Chakravarti. So the useful data for this question is that you have given a system whose output y of n, which will be given by x of n, where x of n is the input, which will convolve with impulse response of that system or any filter or filter. So the second one is that in frequency domain, this will give y of e to the power j omega is equals to x of e to the power j omega multiplication with filter transfer function, that is h of e to the power j omega. Okay, so you have given that filter h of n, which is equals to 1, a and b, which is starting from 1, that is n equal to 0, and for n less than 0 the h of n is 0, and for n greater than 2 h of n is 0. So you can write h of n in terms of delta function is equal to delta of n plus a times delta of n minus 1 plus b times delta of n minus 2. So this is your h of n. That filter response is given, where I am using this representation as, so suppose if you have given any discrete time signal a1, a2 and a3 whose n equal to 0, so this is n equal to minus 1 and this is n equal to plus 1. So you can write this one as in terms of delta function, that is a1 times delta of n plus 1 plus a2 times delta of n plus a3 times delta of n minus 1. So I am using this property to represent this h of n sequence. So you can find h of e of j omega, which is equals to the Fourier transform, the discrete time Fourier transform of delta of n is 1 plus a times e to the power minus j omega plus b times e to the power minus 2j omega. So you have given that y of n is 0 for input x of n equal to c1 e to the power minus j pi by 2 n plus c2 e to the power j pi by 2 n. So for this section you can find omega equal to pi by 2. So if output y of n equal to 0 and if xn is not given 0, then this h of e's j omega should be equal to 0 for omega equal to pi by 2. So by putting omega equal to pi by 2 in this h of e to the power j omega expression, where h of e to the power j omega is given as 1 plus a e to the power minus j omega plus b e to the power minus 2j omega. So by putting omega equal to pi by 2, you will get h of e j omega at omega equal to pi by 2 is equals to 1 plus a e to the power minus j pi by 2 plus b e to the power minus j pi. So this should be 0 for yn equal to 0. So this becomes 1 minus ja minus b equal to 0. So in the question from option D, that is b equal to 1 and a equal to 0, is only satisfying this equation. So this becomes 1 minus 1 equal to 0. So option D is correct option. So option D is correct answer for this question.